Hey, happy Monday, everybody. Here's today's warm up. You know the drill. If you want to do a print screen and go print this out so you don't have to copy, then you're one of the lucky kids. Uh, I'm not even that lucky. I write them up every day. Uh, Either way, copy it down. Okay, look over it, start it. After you press pause, come back if you need hints on anything, or come back when you're all done to check your answers and follow along with us. Okay? All right, see you in a little bit. Okay, here we are back again. Hopefully you did well on that. Let's see. Okay, don't forget on these diamonds, we have the product on top. That's the answer to a multiplication problem. And the sum on the bottom, that's the answer to an addition problem. So for this first one, we're looking at two numbers that have a product of 42 and a sum of 13. And again, I encourage you to use those words. Okay, as you're doing this, talk to yourself. Ask yourself that question. What two numbers have a product of 42 and a sum of 13? The more you use them, the more familiar you are with them, the more you own them, and then you become bilingual, right? You speak English and Mathish. All right. So what two numbers have a product of 42 and a sum of 13? Yep, 6 and 7. Good job. How about 35 and 12? And again, I write this little multiplication sign on top and addition on the bottom, just so it reminds me what we're doing. And what two numbers work there? 35 and 12. 7 times 5 is 35. Good. Then 7 plus 5 is 12. All right, 24. How do you say that? 24 what? Thousandths and 46 hundredths. What two numbers? Oh man, this is hard, huh? Not that hard, really. You're starting to think to yourself, what numbers have a product of 24? And you're thinking 2 and 12, 3 and 8, 4 and 6. Ooh, 4 and 6. So now I'm thinking it's going to be a 4 and a 6. In what way can I move those decimals to make that work? And in this case, it's just 4 tenths and 6 hundredths. And remember, your number one step when you're multiplying decimals is to pretend there's no decimal. Pretend there's no decimal. I got 4 times 6 is 24. And then I have to go back and see how many places I moved the decimals over so I was able to pretend there wasn't a decimal. Remember, if you get the decimal over on the right of the number, then you can pretend it's not there because it doesn't matter, right? 4 is the same as $4.00. So in this case, I had to move it over one spot. In this case, I had to move it over two spots. I put those together. That's a total of 3 spots. And I got to go back that many spots in my answer. 1, 2, 3. What do you do here? Fill in the egg carton. Good. 24,000. So that works. Okay. Now, once you get that first one, if you didn't get this one, press pause and go try it now that we know the answer to this one, because it's very similar. Okay? All right, what do we have here? What numbers multiply together equal 56? Well, 7 times 8, right? And I have a 7 and 8 there. I'm going to go play with this and see if it works. 7 tenths and 8 hundredths. Again, 7 times 8. I'm pretending there's no decimal. 56, but I went over one spot there, two spots there, so I have to, that's a total of 3. Got to go back 3 spots in my answer, and that's how I get that. And remember what the rule is when you add or subtract or compare decimals. That's when you want to stack them and line up the decimal. Okay, so when I'm adding these, and that looks a little weird, so what do you do if it looks weird like that so it doesn't look so weird? And it actually helps you get it right if you do that, is you fill in zeros to the right of the decimal. So 0 and 8, 7 and 0, the decimal comes straight down, and that works when I add. All right, good job. Prime factorization. Okay, when we do this, we usually start out with the factor tree. And remember, to make a factor tree, you're just saying what two numbers multiplied together equal that. Now, some people say, well, 12 times 5, because that's on the clock, right? That's 60. Some people say, oh, 6 times 10 or 2 times 30. It doesn't matter how you start. You're still going to end up with the same spot at the end if you do everything right, right? So 6 and 10 is what I'm going to start with. What two numbers multiplied together equals 6? That's 3 and 2. And what multiplied together equals 3? Well, only 3 and 1. And if I said 3 and 1 here, I would have another 3, and I'd have 3 and 1. I would never finish, right? Remember, no ones are allowed. Why? Because once I get to a number that only 1 and itself goes into, I circle it, and that's what's called a prime number. That's why we call this prime factorization, right? All right, how about the 10? 2 and a 5. And both of those are prime, so I'm circling them. You should probably start a list of prime numbers somewhere in your math folder, right? It's good to memorize prime numbers, right? 2, 3, 5, 7, 11, 13, 17, 19, right? 21's not prime, right? But it's good to start memorizing those. It's good for you. It's nice to have those handy. It's kind of like facts, right? So now I take these numbers that I've circled at the bottom and I put them in order. Make sure you put them in order. So I have 2 2s. I'm going with those first, and make a multiplication problem. So the prime factorization of 60 is 2 times 2 times 3 times 5. Okay? And can you rewrite that using exponents? Those are 2, right? So 2 to the second power times 3 times 5. And can you say 2 to the second power in another way with one word? 2 squared times 3 times 5, right? So again, practice saying prime factorization, practice saying 2 squared, and then when mom says, what'd you learn today? Instead of saying, nothing, right? Say, I learned that the prime factorization of 60 in exponential form is 2 squared times 3 times 5. Pass the ketchup, right? I have fun with that, right? You just say it all nonchalant. You can do that if you practice saying it once in a while, okay? Have fun with it. All right, 61. What numbers go into that? Well, let's start checking. Does 2 go into it? No. How do I know? Because it's not even. It ends in a 1, right? And 2 only goes into even numbers, and they all end in 0, 2, 4, 6, or 8. Does 3 go into it? What's that trick with 3's again? Remember, you add the digits. 6 plus 1 is 7. Does 3 go into 7? So 3 won't go into that. What's the trick with 5's? Well, it has to end in a 5 or 0. Think of the 5's. 5, 10, 15, 20, 25, 30, right? They all end in a 5 or 0. That doesn't, so 5 won't fit. What's the trick with 7's? There is no trick. You got to divide. I always have said that, and actually there is a trick with 7's, but for small numbers, it's not worth learning the trick. It's easier to just go divide. So 7 times 8 is 56. I have a remainder, so 7 won't fit into it. Do I have to check all the numbers all the way up to 61? No, you don't. When do you get to stop? That's an important thing to know. You want to learn when do you get to stop so you don't work too hard, right? I don't want you guys working too hard. So when do I get to stop? You get to stop when you've checked the number times itself is bigger than the number you're looking at. So if I'm looking at 61, I need a number times itself bigger than that. Well, I just checked 7. What's 7 times itself? 49. That's not big enough, right? So I have to go to the next prime number. Now, what's 11 times 11? That's 121, right? So once I check 11, I don't have to do anymore, right? And 11 times 5 is 55. 11 times 6 is 66. So 11 doesn't fit. So this is a prime number, okay? Factor seed on that one, right? All right, 62. That's even. I know 2 goes into it. How many times? And I circle a 2, and 31 is actually prime 2. Again, if you want to double check, does 2 go into it? No, it's not even. There's 3, because 3 plus 1 is 4. Nope. Doesn't end in a 5 or 0. 7 times 4 is 28. Nope, I'm going to have a remainder. And 7 times 7 is 49. That's bigger, so I'm done. I just checked those 4 numbers. Prime factorization of 62 is 2 times 31. Okay, we're rolling. How about the 63? You guys know that's one of the 9's, huh? All right, 6 plus 3 is 9, so I know 9 goes into it, and also 3 goes into it, right? The 9 is 3 times 3. Uh-oh, I did 9 times 3, right? That's not 9 times 3. What is it? Thank you for catching that for me. 9 times 7, right? So the 9 turns into a 3 and 3. What do I do with the 7? I circle it. So it's already in order for me. 3 times 3 times 7. And can you rewrite that with exponents? Good. And what do we call that? Exponential form. The prime factorization of 63, an exponential form, is 3 squared times 7. Okay. Okay, good job. In and out. We haven't done one of these in a while. Remember, in and out, no matter what happens to these numbers going in, the machine's going to do the same exact thing over and over again. So if 0 went in and 1.2 came out, whatever I did to the 0, I got to do the same thing to the 1, do the same thing, right? And if 1 went in, and you guys may have recognized that it looks like all these in 2/10 and they're going up by 1 and 2. So what's going to happen here? 4 and 2/10. Now, will 5 and 2/10 come out here? No, why not? That's the pattern. 1 and 2/10, 2 and 2/10, 3 and 2/10, 4 and 2/10. Why isn't this? Because I had consecutive numbers here, and then I skipped from 3 to 5. Okay, so if 4 went in, 5.2 would come out. If 5 goes in, 6.2 comes out. 6 goes in, 7.2. Is 8.2 coming out? No. Now remember, I skipped 7, 8, and 9. Now, you can figure out 7, 8, or 9, but it's nice to know what the function is. The function is, what am I doing to each number? Okay, and once you learn the function, this is easy. What is the function? Well, that's what you're doing to every number. If x goes in, what's coming out? Whatever went in plus 1 and 2/10. If you figure that out, you figured out the function, and then you could do anything. I can say, what happens if 1,000 goes in? 1,001.2, right? 100, 101 and 2/10. 20, 21 and 2/10, right? Okay, good job. All right, the last problem is a tough one. It's one of those irregular shapes. Some people call them a compound shape because it's made up of smaller shapes. That's good to remind yourself, right? You cannot do this in one step. Remember, you can carry a ton of bricks from the driveway to the backyard. You're strong enough. You just can't do it in one load, right? Same idea when you're doing this problem. Don't think you're going to get it done in one step. Take your time, okay? So let's do perimeter first, because then I'm just measuring them. Remember, meter means measure. Around the rim, right? Around the outside. How far is the ant going to walk if he goes all the way around this? Okay. And when I look at this, I recognize I don't have a number there or there. So before I can go much farther, I have to figure out what goes there, right? Okay. Then I can get the perimeter in the area. So how do I figure out what goes here? Well, I have a 3 here and a 2 there. So really, if that went straight up, made a rectangle, this would be 3, that would be 2, and the whole distance is 9. 3 plus 2 is 5, and 9 minus 5 is, and sorry, I did not draw that very well to scale, did I? Right? I'm going to put this back inside so I recognize that that 9 is what I'm adding for this distance, but I am putting a 4 down for this distance. Okay, how about here? Well, I have an 8, then I went up 4, then I went down 2, so up 4 and down 2, that went up 2, so this must be 8 minus 2, which is good. All right, let's add them up. 9 and 8 is 17, 3 and 4 is 7, plus 2 is 9, 2 and 4 is 6, plus 6 is 12. I get 38. And just to double check, I'm going to go add them a different way. Remember, don't add them the same way, because if you made a mistake the first time, you'll most likely make a mistake the same way the second time. You don't want to do that. Mix it up a little bit. So 4 and 6 is 10, 19, 27, 30, 36. Uh-oh. Oh, I forgot that one. 38, good. So 38 what? Meters, what kind of meters? Just meters. Remember, perimeter is just a length. Area is when we do the square meters, right? Okay, how do you do the area? Well, there's a couple different ways. One way is to, let's make this a rectangle here. Go straight down, go straight down. this rectangle plus this one plus this one. This one is 3 wide and 8 tall. That's 24. 3 times 8, right? This one is 2 wide. How tall is this? Oh, that was 8. This is 4. That must be a 4. So 2 times 4 is 8 square meters. And this is 4 wide and 6 tall. 24 square meters. Add them all up. 4, 8, and 4, that's 16. I didn't line those up very well, huh? 3, 2. So got to be careful when I add. 56 square meters. Let's do it another way just to double check. I like to do this sometimes and turn it into one giant rectangle. So that would be 8 times 9 is 72. But now I'm going to subtract 4 times 2, 8, and 2 times 4, 8. So I'm subtracting 16 from the 72. I'm subtracting this part here that would have gotten cut out of the big one. Okay, and when I do that, 12 minus 6, 6 minus 1, look at that, same answer. All right, good job. We even double checked it. Go start your day after you finish with this, right? All right, see you on Tuesday.